When a company like Samsung makes a move, the world usually pays attention. But this time the reaction has been different, quieter on the surface and explosive underneath, because what Samsung has just revealed is being described by insiders as a silver bomb. Not a marketing buzzword, not a flashy slogan, but a technological shift that could ripple through global supply chains, energy markets, and geopolitics faster than most people realize. And to understand why this matters, you first need to understand how fragile the current battery ecosystem really is, because for years the world has been building its future on lithium-ion technology. Assuming incremental improvements would be enough better density, here lower costs there, but always tied to the same raw materials, the same mining regions, the same bottlenecks. Lithium from South America and Australia, cobalt heavily concentrated in the Congo nickel supplies, increasingly strained, and all of it moving through a supply chain that has become both globalized and politically sensitive. And this is where Samsung's so-called silver bomb enters the picture, because it challenges the assumption that lithium-ion is the only viable path forward at scale. According to early disclosures and leaks from industry analysts, Samsung has been developing a next-generation battery architecture that replaces or drastically reduces reliance on traditional lithium-ion chemistry by integrating a silver-based compound. As a critical component in energy storage and conductivity, and silver, unlike lithium or cobalt, has a very different global footprint, a different mining distribution, and a different role in existing industries, which immediately raises one uncomfortable question for governments and corporations alike. What happens when demand suddenly shifts from one critical material to another, especially one already embedded in electronics, solar panels, medical devices, and military hardware, because silver is not rare, but it is finite. And more importantly, it is already spoken for. And that's why this announcement has made certain supply chain analysts nervous, because if Samsung's technology scales even partially, it could trigger a reallocation of resources on a massive level. Not tomorrow, not next month, but within a few short years. And this isn't speculation pulled from thin air. Samsung SDI has a long history of quietly developing technologies years before public rollout. From solid-state research to advanced anodes and cathodes, often filing patents long before competitors catch on. And recently, several patents surfaced referencing silver-carbon composite structures designed to improve ion flow, thermal stability, and charging speed, which in simple terms means batteries that charge faster, degrade slower, and operate more safely under stress. Three of the biggest problems holding back current battery systems. And if you're wondering why silver, the answer lies in physics and chemistry. Silver has the highest electrical conductivity of any metal. It handles heat exceptionally well, and it resists corrosion, qualities that become extremely valuable when you are pushing batteries to charge faster and store more energy in smaller spaces, especially for electric vehicles, grid storage, and aerospace applications. And this is where the global implications start stacking up, because battery demand is no longer just about smartphones and laptops. It's about national infrastructure, power grids, military readiness, and economic independence. Countries are racing to secure battery supply chains, the same way they once raced for oil. And a technology that shifts the materials equation instantly reshuffles that race. Imagine a world where lithium demand growth slows, cobalt dependency declines, and silver demand quietly explodes. Markets would react, mining investments would pivot, and countries rich in silver would suddenly gain strategic leverage they didn't have before. Places like Mexico, Peru, and China, which already control significant portions of global silver production. And this also raises another uncomfortable reality: recycling, because silver is recyclable at high efficiency, far more so than lithium, which could change the economics of battery recycling entirely, making closed-loop systems more viable and profitable. Something governments have been struggling to achieve with current battery chemistries. But there's another layer to this story that makes it even more disruptive. Samsung is not just a battery manufacturer. It's deeply integrated across consumer electronics, semiconductors, displays, and energy solutions, which means if this technology works, Samsung doesn't have to wait for the world to adapt. It can deploy it internally. First, phones, wearables, home energy systems, even experimental EV platforms, creating a real-world testing ground at massive scale, something most startups and even established competitors simply can't replicate. And that internal advantage could accelerate adoption faster than analysts expect, catching suppliers, competitors, and regulators off guard. Because supply chains are slow to change, but technology doesn't wait. And this is why some experts are calling this a silver bomb. Not because it's flashy, but because it's silent, strategic, and potentially destabilizing to the existing balance of power in energy storage. And we're only scratching the surface here, because the real question isn't whether this technology works in a lab. It's what happens when it starts working in the real world. At scale across industries that were never designed for it. And in the next part, we're going to break down exactly how this technology could disrupt global supply chains, who stands to win, who stands to lose, and why some companies may already be too late to react. To understand how disruptive the silver-based battery technology could be, you have to zoom out and look at how global supply chains actually behave under pressure, because supply chains are not just logistical systems. They are ecosystems built on long-term assumptions, contracts, infrastructure, and political agreements. And when one of those assumptions changes, everything downstream starts to wobble. Right now, the battery industry is optimized around lithium-ion. From mining equipment to chemical processing plants, from shipping routes to recycling facilities, entire economies have aligned themselves around feeding this machine, and Samsung AES Move threatens to introduce a parallel path that doesn't neatly fit into the existing structure, because silver is mined, traded, and stored differently. It has different purity requirements, different refining processes, and different price dynamics, and that matters. Because price volatility alone can make or break large-scale adoption, silver markets have historically been influenced not just by industrial demand, but by investment demand, speculation, and even monetary policy, which means that if battery manufacturers suddenly begin competing with investors, solar producers, and electronics makers for the same material, the ripple effects could be immediate and intense, and this is where governments enter the picture. Because many countries have spent the last decade trying to reduce dependence on lithium and cobalt supply chains, dominated by a small number of regions and actors, particularly China. And while silver production is also influenced by China, it is far more geographically diversified, which on paper sounds like a win for supply security. But diversification also means complexity, more suppliers, more regulatory environments, more chances for friction, and companies that fail to adapt quickly could find themselves locked into outdated sourcing strategies, paying higher costs while competitors pivot to new contracts and partnerships. And then there's manufacturing. Battery factories are not easily retooled. They are capital intensive, highly specialized facilities designed for specific chemistries, changing electrode materials, binders, or internal architectures, often requires years of redesign, testing, and certification. And Samsung's advantage here is experience. It has already navigated multiple generational shifts in battery design, from early lithium-ion to high-nickel cathodes, and experimental solid-state prototypes, which means it likely anticipated the manufacturing challenges long before the public ever heard the phrase silver bomb. And that preparation could translate into a significant time advantage, because while competitors scramble to understand the implications, Samsung could already be negotiating supply agreements, securing patents, and building pilot lines. And time in this industry is everything, because whoever scales first sets the standards, influences regulations, and locks in customers, especially automakers and energy providers, who plan infrastructure decades in advance. And speaking of automakers, this is where the disruption becomes impossible to ignore. Electric vehicles are the largest growth driver for battery demand, and they are also the most sensitive to cost, safety, and charging speed. If a silver-enhanced battery can deliver faster charging with lower thermal risk, even at a slightly higher material cost, it could change consumer expectations overnight, because range anxiety is no longer just about distance, it's about time, how long it takes to get back on the road. And if Samsung's technology reduces charging time significantly without compromising lifespan, automakers will face enormous pressure to adopt it, or risk falling behind. And that pressure would cascade through their suppliers, forcing rapid changes in sourcing, design, and manufacturing. And not everyone will survive that transition. Smaller suppliers with limited capital could be squeezed out, while larger, more agile players consolidate power. And then there's the geopolitical angle, because materials equal leverage, countries that control critical resources gain influence, and silver-rich nations could find themselves suddenly courted by multinational corporations and foreign governments. Investment flows would shift. Mining projects once considered marginal could become strategic, and environmental debates would intensify, because increased silver mining raises its own concerns around land use, water consumption, and waste, meaning that the sustainability conversation doesn't disappear. It simply moves to a different battlefield. And regulators will be forced to respond, often slower than the market itself, which creates windows of opportunity for companies willing to take calculated risks. And Samsung has never been shy about playing the long game. It invests heavily in R&D precisely to create moments like this, where a single technological pivot reshapes competitive dynamics. But the biggest disruption may not come from what this technology replaces, but from what it enables, because improved conductivity and thermal stability open doors to entirely new battery formats, flexible designs, higher density packs, and hybrid systems that blur the line between batteries and supercapacitors. And those possibilities extend beyond consumer tech into aerospace, defense, and grid-level storage, sectors with budgets large enough to accelerate adoption even if costs remain high initially. And once those sectors move, the rest of the market follows. And this is why some analysts believe the silver bomb is less about silver itself and more about timing. The world is already under strain from energy transition demands, supply chain fragmentation, and geopolitical tension. Introducing a disruptive battery technology into that environment doesn't just change markets, it amplifies existing pressures. And in the next part, we're going to look at who stands to benefit the most from this shift, who is most at risk, and why the real winners may not be the ones people expect. When disruptive technologies emerge, the instinct is to look for obvious winners and losers, but history shows that the real outcomes are usually more subtle. And Samsung's silver-based battery concept is a perfect example of that, because the companies most at risk are not always the weakest ones, but the most rigid, those deeply invested in existing lithium-ion supply chains with little flexibility to pivot. And this includes not just battery manufacturers, but mining companies, chemical processors, equipment suppliers, and even financial institutions that have poured billions into lithium, cobalt, and nickel projects based on long-term demand forecasts. And if those forecasts start to wobble, even slightly, the impact on valuations and investment strategies could be significant, because markets hate uncertainty. And a credible alternative changes the risk calculus overnight, but on the flip side, the biggest beneficiaries may not be the battery giants themselves, but the ecosystem around silver, from miners and refiners to recyclers and logistics providers. Companies that have historically treated silver as a secondary or byproduct metal could suddenly find it becoming a primary revenue driver, and that shift could unlock capital, innovation, and political attention in ways that haven't been seen in decades. And then there are governments, some of which have been quietly stockpiling strategic materials, rethinking industrial policy, and offering incentives for domestic battery production. A technology that relies less on lithium and cobalt could align perfectly with those goals, particularly for countries that lack lithium reserves but have access to silver or strong recycling infrastructure. And this could lead to new alliances, trade agreements, and industrial strategies, reshaping the geopolitical map of energy storage. But beyond economics and politics, there's a technical reality that makes this story even more compelling. Battery failures are one of the biggest barriers to mass adoption. Fires, degradation, and thermal runaway are not just engineering problems, they are trust problems. And silver's thermal and conductive properties could dramatically reduce these risks, especially under high load or fast charging conditions. And if consumers begin to associate a new generation of batteries with improved safety and reliability, the psychological barrier to adoption drops, accelerating demand across multiple sectors. And that acceleration creates feedback loops. Higher demand drives more production lowers costs, lower costs drive wider adoption. And suddenly, a technology that once seemed niche becomes standard. And this is where Samsung's strategic positioning becomes critical, because it doesn't need to win every market. It just needs to seed enough adoption to tip the balance. Once competitors are forced to respond, the direction of travel is set, even if Samsung doesn't dominate every segment. And this strategy has precedent. We've seen it with display technology, memory chips, and even smartphone components, where early leadership allowed Samsung to influence standards and supply chains for years. And another underappreciated aspect of this shift is recycling economics. Lithium-ion recycling has struggled to become profitable without subsidies. Due to complex chemistry and material loss, silver, by contrast, is highly recoverable, with established recycling processes already in place. Integrating silver into battery design could dramatically improve end-of-life value, making batteries assets rather than liabilities. And that changes how companies think about ownership models, leasing, second-life applications, and circular economies, which regulators and investors increasingly care about. And this could give Samsung an edge not just technologically, but in ESG narratives that influence capital flows and public perception. And then there's the timing factor again. Global energy demand is rising, grids are under pressure, renewable energy needs better storage, and governments are pouring money into infrastructure projects. A more stable, efficient battery technology. Arriving at this moment doesn't just compete with existing solutions, it fills gaps that current technologies struggle to address, especially at scale. And this raises a critical question. Is the industry ready for this shift? Because readiness isn't just about technology, it's about mindset, policy, and coordination. And many players are still fighting yesterday's battles, optimizing lithium supply, securing cobalt contracts, lobbying for mining permits while the ground beneath them may already be moving. And that is why some experts believe the real disruption won to be announced at a flashy product launch. It will show up quietly in revised contracts, new pilot projects, unexpected partnerships, and subtle changes in investment flows, signals that are easy to miss until the pattern becomes obvious, and by the time it does, the window to react may already be closing. And in the next part, we're going to explore the biggest obstacles this technology still faces, why it hasn't already taken over the market, and what needs to happen for the silver bomb to truly detonate on a global scale. For all the potential and disruption surrounding Samsung's silver-based battery technology, It's important to understand that breakthroughs don't become revolutions without overcoming serious obstacles. And this is where reality tends to slow down even the most promising ideas, because while silver has exceptional properties, it also comes with challenges that can't be ignored. The first and most obvious is cost. Silver is significantly more expensive per unit than many materials currently used in batteries, and even small increases in material cost can have outsized effects when you're producing millions of units, especially for price-sensitive markets like electric vehicles and grid storage, which means that for this technology to scale, Samsung has to prove that the performance gains justify the added expense, either through longer lifespan, faster charging, higher energy density, or reduced safety costs. And that's not a trivial equation. It requires years of data, real-world testing, and convincing some of the most conservative buyers in the world to take a calculated risk. And then there's the issue of supply elasticity. Silver production cannot simply double overnight. Mining projects take time, permits, infrastructure, and social approval. And if demand rises faster than supply, prices could spike, undermining the very advantages this technology promises. And this is where Samsung's patent language becomes interesting, because it suggests not a pure silver battery, but a hybrid architecture that uses silver strategically in thin layers, composites, or critical interfaces, maximizing impact while minimizing volume, which could make the economics far more viable. But it also means manufacturing precision becomes critical, tolerances tighten, quality control becomes more complex, and any defect could undermine performance or safety, and that raises the bar for production even higher. Another obstacle lies in standardization and certification. Batteries are among the most heavily regulated components in modern technology. Especially in automotive and energy infrastructure, new chemistries must pass rigorous testing for safety, durability, and environmental impact, a process that can take years. And while Samsung has the resources to navigate this, widespread adoption requires industry-wide confidence. Insurers, regulators, and consumers all need to be convinced. And that doesn't happen overnight. And then there's competition because Samsung is not operating in a vacuum. Other companies are exploring solid-state batteries, sodium-ion alternatives, lithium-sulfur designs, and hybrid capacitor systems, all promising to reduce reliance on scarce materials and improve performance, and the market may not settle on a single winner. Instead, different technologies could dominate different use cases, fragmenting adoption, and slowing the kind of global shift that truly breaks supply chains. And yet, despite these obstacles, what makes Samsung's move different is its strategic patience. This is not a company betting everything on one announcement. It's layering innovation on top of an already dominant position, testing, iterating, and waiting for the right moment to scale. And that moment may be closer than it appears because external pressures are aligning. Governments want safer batteries, consumers want faster charging, industries want supply chain resilience, and investors want technologies that promise long-term stability rather than short-term hype. And if Samsung can demonstrate even a modest advantage across these dimensions, adoption could snowball, starting in high-end applications where cost is less sensitive, then gradually moving downstream as manufacturing improves and prices fall, a pattern we've seen repeatedly in technology transitions, from semiconductors to displays to renewable energy. And this leads to a deeper question about innovation itself. Sometimes disruption doesn't come from replacing everything at once, but from inserting a small strategic change into a system that's already under stress and letting the consequences unfold. And silver, in this context, becomes less a material and more a catalyst, a way to unlock performance gains that force the rest of the system to adapt, willingly or not. And that's why the term silver bomb resonates, because the explosion isn't immediate, it's delayed, unfolding over years as decisions made today ripple outward. And in the final part, we're going to bring all of this together, what this technology means for the future of energy, how soon we might see its impact in everyday life, and why paying attention now could give you a clearer view of where the world is headed next. When you step back and connect all the threads, Samsung AS so-called silver bomb starts to look less like a single technological announcement and more like a signal that the era of incremental battery improvements may be giving way to a period of structural change where material supply chains and strategic priorities are all being reconsidered at once. And this matters because batteries sit at the center of almost every major transformation happening right now, from transportation and renewable energy to consumer electronics and national security. And any meaningful shift in how batteries are built sends shockwaves far beyond the lab. And while it's unlikely that silver-based batteries will replace lithium-ion overnight history, suggests that transitions don't need to be total to be transformative, they just need to be credible. And Samsung's involvement alone makes this concept credible in a way few others can. Because this is a company with the scale, capital, and patience to push a technology through the long, uncertain middle phase where many innovations fail, and that's why governments, competitors, and investors are paying close attention, even if the public conversation hasn't fully caught up yet. And in practical terms, what this means for everyday life may arrive subtly at first. Devices that charge faster and stay cooler, batteries that last longer without noticeable degradation, energy storage systems that feel more reliable and less risky, small improvements that compound into a noticeable difference over time. And as these improvements accumulate, expectations shift. What once felt impressive becomes normal, and older technologies begin to feel outdated, not because they stop working, but because something better has quietly raised the bar. And this is often how real disruption happens, not with a dramatic collapse, but with a gradual loss of relevance. And for companies and countries that fail to anticipate that shift, the consequences can be severe: stranded investments, outdated infrastructure, and missed opportunities that are hard to recover from. And this is why paying attention to early signals like this matters, even when the details are incomplete and the timeline's uncertain, because the future rarely announces itself clearly. It reveals itself in fragments, patents, pilot projects, quiet partnerships, and subtle changes in strategy. And Samsung's Silver Bomb fits that pattern perfectly. It's not a finished product yet, it's a direction. And directions, once set, are hard to reverse, especially when they align with broader economic, technological, and political forces. And as the global push for energy, independence, sustainability, and resilience accelerates, technologies that reduce bottlenecks and improve performance gain outsized influence. And silver, with all its advantages and challenges, may become one of the unexpected pillars of that next phase. And whether this specific approach becomes dominant or simply accelerates innovation across the industry, its impact will be felt, because competition breeds progress, and progress reshapes the world in ways that often only become obvious in hindsight. And that's why now is the moment to watch closely, to question assumptions, and to recognize that the future of energy storage is still being written. And if you want to stay ahead of these shifts, to understand not just what's happening, but why it matters, keep following this conversation, keep exploring the technologies shaping our world. And if you found this breakdown useful, make sure to stay tuned for more deep dives like this. Subscribe to the channel and keep watching, because the next transformation may already be closer than you think.